Greetings everyone, it's Anand Sumesh here. So today in this video I am going to be doing my first ever educational video of this channel, and it's on the topic of algebraic identities. So I'll be taking a class on the 4 basic algebraic identities, including one extra identity, which is the a plus b plus c the whole square identity. Make sure to slap like and subscribe to your channel because there's another big announcement coming at the end of the video. So let's proceed to the lesson. Okay, so let's get started. That was cool. Okay guys, so the 4 basic identities are these, and the black one is what I'm going to be giving most importance to. So guys, let's start. So a plus b the whole square is equal to a square plus 2ab plus b square. So how do we get that? Let me explain. So a plus b the whole square can also be written that this sign means implies. You need to learn all these signs because these can be very important during your board years. So a plus b the whole square can be expressed as a plus b into a plus b. So let's multiply term by term. A into a is equal to a square. Okay. Next, a into b, ab. B into a, also ab. Now, why did I not write ba? Okay, ba is correct, but ab is also right because we learned something known as commutative property, where it is satisfied by only 2 operations, which is addition and multiplication. Okay, so in this case it's multiplication of 2 variables. Constants and variables are 2 things which you also need to know. Constant can be any number, 0, minus 1, minus 2, minus 3, 3, 4, it goes to negative infinity and positive infinity. But variable, it can be any letter, A to Z, anything. So what that means is constant, we know the value because the value is always going to be constant. Let's take 1. The value of 1 is always going to be 1. But let's take b. We don't know the value of b. B is always going to be unknown. It can be any number, right? So that is what we mean by variables and constants. So b into a. Now same commutative property, ba, which means it is b into a, can also be expressed as a into b. That's why it has been given as ab plus ab. Okay. Now these are 2 like terms. Like terms means they are of the same terms, that is of the same variable. So ab plus ab plus ab is equal to 2ab. So let me just write that down, 2ab. Okay, now b into b is b square. See, just got the identity. A plus b the whole square is equal to a square plus 2ab plus b square. So that's how you derive the first one. Now guys, a very important fact, a plus b the whole square and a is equal to a square plus 2ab plus b square. This must be by hearted. These basic 4 identities must be by hearted at all costs. Actually all identities, because these are very important things. Okay guys, so into the next one. So the next one we discussed was a minus b the whole square. So it's all same. Now a minus b the whole square can also be written as a minus b into a minus b. Same property. Okay, now how do you derive? We are going to be doing the same type of multiplication. A into a, same, a square. Now here is the problem. A into minus b, the answer will become minus. So we got a into b as ab here, hence this will be minus ab. Same over here. Again b into b is b square. Yeah, so I'm just going to be writing this small step. You don't need to write this, just for your understanding. Minus into minus is always equal to plus. Minus, if you see just a minus, it means it's 1 in front of. So same property, minus b into minus b is equal to b square. Okay. So let's see, a square minus, again like terms, so minus 2ab plus b square. There, we derived it again. So this is very easy actually. Once you have got the momentum for this, you are on fire. Just go on. So okay guys, now we are going to go on to the third identity. So I know what you're thinking right now. Why did it come as minus over here? Now this is just for junior classes. Senior, it's an exception. So just pay attention guys. So if it's positive and positive, it's not positive here, I'm just telling. If it's, let's say 1 into 1 positive, I haven't written that because it's understood, is equal to positive 1. Okay. Now minus, we already know the case. Minus into minus is always plus. But what if it is positive 1 into negative 1? Then the answer will become negative 1. So this rule you must be thorough with, because this is a very important rule. So be very thorough with this, and that's how you can derive this. So a plus b into a minus b. A into a, you will get a square. Over here you will get minus ab. Again over here you will get plus ab and minus b square. So you can see minus ab and plus ab, they are like terms but of the opposite sign. Now we learned something called additive inverse in 6th standard, I believe. So if a number is negative, let's say minus 1, the additive inverse of this would be positive 1. If it's positive 1, it would be negative 1. So same rule applies here as well. So if it's coming in the same equation, then you can just cut them out. This would be 0. Therefore we have also derived this as a square minus b square. So that's the third identity done. Okay guys, so now the fourth identity. Fourth identity is x plus a into x plus b. Now what is quite unique with this is that in all these cases we have 2 variables, whereas in this we have 1, 2 and 3 variables. Still it's very easy to solve. If you again derive it, x into x is obviously x square. Next you will get dx plus a into x, you will get ab. Now this is a bit like distributive property. X can be taken outside. So x square plus x into a plus b plus ab. Or this is right, but a more refined version is x square plus a plus b. Always remember to put this bracket into x plus ab. Hence we have derived all 4 identities in a very fast way. So guys, make sure to remember this and this. For all these identities you must know the product side and the factorized side. Okay guys, so now we are going to be looking at the 5th identity. So this can also be written as a plus b plus c into a plus b plus c, just like how we derived all those identities. So a into a square, b into b plus b square, c into c plus c square. So I know what you guys are thinking, why did I go with each variable at a time like a square? That's okay, you can do it in your order, but I would prefer to do the exponents first, then go on to the other part. Okay, so is the exponents done. Next you're going to get ab plus ac. Okay, Next B into A, again AB plus BC. Next plus AC plus BC. Okay, now let's add. A square, always keep the exponents first, plus B square plus C square. Now here you have to notice something. If you are confused in adding the terms, then it's okay. I'll tell one easy method. If you can add all these in a very quick way, that is AB. If you think that you might make a mistake, that you might add it again or something, you can just tick it off. Let's say AB plus AB, you can take it off, write 2AB. Now I'm going to be underlining the last term so that I can tell one more thing. 2AB plus, so BC plus BC is equal to 2BC. Next, AC plus AC is equal to 2AC or 2CA. Now the reason I underline the last variable is because the ending of one term, or in this case B, or the variable ending at one term B, must be the starting variable for the next. So you can see B is the starting here and B is also ending here. So that's the reason why I have underlined this. C is ending over here, C will start over here. So that's just for uniformity, it's not compulsory, but just to be more neat, and if you want more uniformity you can use this method. Now let's learn something else which might be new for you. It's called extension. So we learned a plus b the whole square, so you will do a square plus 2ab plus b square. Now how do you extend that? So in some cases they might give the value of ab and a. They might tell you to find the value of b, or during that time you can use this extension. So this first one is known as a square plus b square. Actually both are a square plus b square, but there are two cases to it. So this is the case 1 which I am explaining. So a plus b the whole square, as all of us know, is a square plus b square plus 2ab. So a plus b the whole square is equal to a square plus b square plus 2ab. I have underlined that because it will go to this side. This is known as transposing. That's why I have drawn this arrow. So plus here will become minus there, equal to a plus b the whole square minus 2ab is equal to a square plus b square. So I have made this into an equation so that this can be solved very easily. So a plus b the whole square is obviously a square plus 2ab plus b square. So plus 2ab and minus 2ab will be cancelled, which means a square plus b square are the only terms left, and then there are a square and b square over here, two variables. So that's how you can equate that. For case 2, same, it is a square plus b square, but instead of the positive sign it is negative. So a minus b the whole square is equal to a square plus b square minus 2ab. A minus b the whole square is minus 2ab, not plus 2ab. Minus will go over here, transpose will become plus. Again, a minus b the whole square plus 2ab is equal to a square plus b square. So minus 2ab plus 2ab, cut. You will get a square plus b square is equal to a square plus b square. Hence, guys, those are the main important things you must learn. So now let's solve some question. That is x plus 8 into x minus 10. No need to worry. Although there's a minus sign over here, just solve it like how we studied. So that will become x square plus a plus b into x. So a plus minus 10. Obviously a plus isn't needed because minus will be dominant. Put that in a bracket into x plus minus a minus 10 into 8. And put that in a bracket, which is equal to x square. This will be minus 2. So minus 2 into x will be minus 2x minus 80. Now the second one. In the second one, they have told to evaluate. Evaluate means to find the answer. You can write this as 100 plus 4 into 100 minus 4. This is a plus b into a minus b. It's equal to a square minus b square. So let's do it. So a plus b, a minus b, say a square minus b square. 4. 1 followed by 4 zeros, which is 10,000 minus 16. Hence, you will get the answer of 9984. Is it clear? A plus b into a minus b. So x minus y by 10. So now we can easily find the answer. X plus y by 10 into x minus y by 10. So this is the final answer. That is 1 by 4a minus half of b plus 1 the whole square. This is of the form a plus b plus c the whole square. So a square plus b square plus c square to multiply a into b. This will be negative. So 4 into 2 is 8. So 1 by 8 ab. Put that 2 outside because we can cancel the denominator. B and c. Again, since c is 1, there will be no change in value. You can just write it as such. A and c. Again, no value change. So let's write it. 1 by 16 a square plus square minus will be cut. So I will become 1 by 4 b square plus 1. Now 2 and 2 cut 4. So will become, since it's 1, we can substitute this as ab. So minus ab by 4. 2 and 2 cut. So it will become minus b. Same property. Plus 2 and 2 cut. A by 2. So you can either leave the answer like this, but there's one more way to make it better, again using the same property. So you're going to get a square divided by 16 plus b square divided by 4 plus 1 minus ab by 4 minus b plus a by 2. So this is also fine. So thanks for watching this video. So don't forget to revise. So now it's time for the announcement. At 69 subs, I'll be doing my first ever instrument collection reveal. So subscribe now and slap like. And one more thing, at 75 subs, I'll be doing a gear reveal. Till then, keep slapping.